Good afternoon, everyone. I'm Valentina Zega from Polytechnic di Milano, and today I will speak about a metaplate in MEMS for innovative application. This work comes from a collaboration between Polytechnic di Milano, Italy, and the Nanjing University of Science and Technology, China. A metaplate is a periodic arrangement of planar unit cells that experiences the extraordinary property of the bandgap opening, which means a frequency range where propagation of elastic and acoustic waves is not allowed. The unit cell consists in an inner mass connected to the external frame through folded springs that, despite their planar geometry, allow the motion of the mass along the three orthogonal directions. In the first proposed application, the metaplate is employed as a tunable mechanical filter. Thanks to the bandgap property, it is then possible to obtain a complete transfer of the signal for certain ranges of frequencies and a complete attenuation of the signal for the frequencies inside the bandgap. Tunability is achieved by exploiting the electrostatic tuning of parallel plate capacitors located on the substrate under the central masses of the unit cells. A prototype will be fabricated by ST Microelectronics and tested in the following months. In the second proposed application, the idea is to interpose the metaplate between the substrate and the silicon layer, where the resonant device is kept in oscillation, in order to isolate it from unwanted external vibrations. When external vibrations act on the package, they propagate to the silicon substrate and then to the metaplate. Thanks to its bandgap property, the metaplate strongly attenuates such vibrations, and only a small amount of the external vibrations reaches the resonant device. A first macro-scale prototype has been fabricated through the 3D printing technique and tested as a proof of concept. Once the working principle has been tested at the macro scale, we moved to the MEMS scale with a metaplate for vibration isolation applications in MEMS resonant accelerometers operating at 10-20 kHz. The bandgap is shown for frequency between 11 and 16 kHz in agreement with the resonant frequency of the resonant device we want to isolate. We are currently working on the fabrication and test of a fully integrated MEMS resonant device plus metaplate. You can find more details on our work on the poster, but feel free to ask any questions at the discussion panel and by email. Thank you for your attention.